But for unimodal maps, we can do much better. And the main idea is topological. There is a diffeomorphism. It turns out it's not smooth, but it won't matter. Here it's saying that for a map like this, there is another map which is really easy to understand. So there's a tent map, which has one branch goes up, one branch goes down, but this is simple. Its slope is 2, and this map just multiplies by a factor of 2. So it's really easy to understand. But the really important thing is that I can associate with the critical point, I can associate an interval, saying that map actually cannot reach all the way to the length of unit interval. You know, it doesn't stretch far enough. It can reach only that far. So that's a dike map. That's, again, the Dutch theme of today. The Dutch are good in speed skating and making dikes. And that's a very simple map. And topologically, these guys are the same. So you can write some conjugacy, which turns out maybe not so easy to do in practice, but there's a topological conjugacy. So if you understand what happens with this map, you will understand what happens with all maps of this type, no matter whether they look like this, or they might look like that, you know, they might look like that. In applications, you'll find very weird maps. As long as they're monotone, you're fine. They're all in the same class. Yes?
Is the vertical axis on the tent map to the right? Yes. Is that an open interval or a semi-open interval? Or
we define it to be contained within 0 and 1.
Fully.
So there
I'm interested in the cusp point. That was all I was thinking about.
this cusp, I think you...
That's why I'm asking if it's open.
Yeah, I think you want to call it an open interval because this cusp is a very special feature. So, good question. So let me... So if the cusp is extremely important for the smooth maps, and if the cusp touches the unit interval, then its future is very special. This point, critical point, maps to the fixed point. So this critical point is called pre-periodic. And the special case that it is prefixed point, which is a special point, case of periodic points. And in that case, you really have to deal with this differently than its infinitesimal neighborhood. And it's very important to understand the topology. And in the book, there is a conjugacy. So as a problem set, ULA map, every point on this map can be mapped into the tent map. So that's called ULA map.